spend a ton amount of time graphing these. This is still the stuff that I graphed with you in the last video during the virtual days where we had to find asymptotes and all that. This is that same stuff. It's still graphed with rational functions. What changes today is we're going to have higher powers. Most of the ones that I did with you on Friday, it was fractions. It was rational, but it was mostly to the first power. So that's what's changing a little bit today. There's 3 scenarios that we'll have to deal with, and that's what I've abbreviated these 3 things over here. So what I plan on doing with you is just graphing one of each of these scenarios and making sure we can do it, because we're going to be able to do most of it in our calculator. So I've got my calculator ready, but what your calculator doesn't tell you are what those asymptotes are, and that's what we talked a little bit in the video Friday. Okay, so this first scenario that I have there, my mumbo jumbo, this was just a way for me to remember what to tell you. The n less than d, so I'm talking numerator and denominator on those n's and d's, so top and bottom. So that means the degree. Remember, degree is the highest power. So if the highest power of the numerator is less than the highest power of the denominator, something's going to happen. If the highest power of the numerator is equal to the highest power of the denominator, something's going to happen. And then the last one, if the highest power of the numerator is greater than the highest power of the denominator, something's going to happen. Okay? This will be number 1. And what we have on number 1, there's no variable at all on top, so there's no degree. So you got a 0 degree and a 2 degree. So the numerator 0 is less than 2. So that's how we would say that.
Wouldn't it be a first?
No, when you got to have a variable. It's the power of the variable. The letter.
Oh.
The letter. Good question though. All right. So I forgot to put my Duma Flotchy on the charger. I don't know if it'll be any good right now or not. Okay, so like Christian just helped us figure out, our numerator has a degree of 0. Our denominator has a degree of 2. So 0 is less than 2. So what that tells us in that situation, number 1 situation, if you save some room to write, is that y equals 0 is your horizontal asymptote. Okay? So that's this axis here. Here's your y equals 0, so that's your horizontal asymptote. Now, we still find the vertical asymptotes the same way as I told you in that Friday video. The vertical asymptote will always be set the denominator equal to 0 and solve. Always. Because you can never have a 0 on bottom, so you can never touch that. But what's going to happen in this case, if you set that equal to 0 and solve, it's not going to be real. Can you see that and follow that? Because this would mean x squared. If I'm trying to solve for x, I would subtract that 1, right? And then you do the square by square rooting, and the square root of -1 is I. So we don't have to worry about a vertical asymptote in this case, okay? But you got to check that and see, but we got an I, so we don't have to worry about that. Okay, so from there, all you do to graph, since we know this is our horizontal asymptote, we don't have a vertical asymptote, you could either make the table and plug in your points like we did, or you can go to your calculator. Either one, doesn't matter. I tried, I think I'd probably be better off going back there. I tried to get my calculator ready so we could go through that together, because that's going to be a time saver for you on the test stuff. Alright, so some of y'all are, I don't know, some people do the division with parentheses. I'm just going to go ahead and try to get it all in there as a fraction if I can. So go ahead and be doing it on yours. I'm going to hit my fraction keys, alpha y equals. So what do we have? 6, and then on the bottom, x squared plus 1. Alright. Okay, so that one kind of reminds me a little bit of a volcano.
Yeah.
Is it touching right there? It is, that's correct. But do you know why? This in some,
Oh, cause it says 6.
okay, it doesn't say error at that in the table, it's kind of what he's talking about. But remember, this would be a vertical asymptote, and we didn't have any vertical asymptotes. So it doesn't have to curve up there like some of the ones you did Friday, right? So it does touch that. So it's not touching this one, that's your horizontal asymptote, so it's just coming along there. So that would be called, where it hits that, would be called a y-intercept. It's intersecting the y-axis. And you can go to your table, I don't know if I can here. No. Oh. You can go to your table and get any of those points that you needed. Okay, so y'all feel comfortable on the calculator with that? All right, so let's do a scenario number 2 here. Oh, I took my book back there. Success or fail or?
Nothing, because I think the place where the screw's supposed to go in is stripped. So I've just got a lens that's barely.
There's no one there.
I don't know.
My lenses are held in on a little screw on each side, and the screw is popped out.
Let's just sum it up this way. He's got a screw loose.
Yeah. Multiple.
That makes sense.
It's all coming to you now, isn't it?
Oh yeah, watching them go
Alright, so here we got y equals 2x squared over x squared minus 9. Now remember, we had 3 scenarios that we were checking for, and it was comparing the degree of the numerator to the degree of the denominator. So our degree on this numerator is 2, and our degree on this denominator is 2. So what kind of sign would compare 2 and 2?
Crazy.
Equals, okay?
I think
So
I'm not the only one with this weird.
So our numerator degree is equal to our denominator degree. What that tells us now is that the coefficient of your numerator over the coefficient of your denominator is going to be your horizontal asymptote. Okay, let's digest all that I just said. The coefficient of the numerator, so this was a 2. The coefficient of the denominator, so that's a 1. 2 over 1, so we're going to have a horizontal asymptote at y equals 2. Okay? So I'm going to go up to 2. And that's where I'm going to draw that dotted line. Now, how do we always find the vertical asymptotes? Denominator equal to 0 and solve. So x squared minus 9 equals 0. Add your 9. Undo the square by square rooting. And don't forget this. That's positive or negative 3, isn't it? So we're actually going to have 2 vertical asymptotes here. So I'm going to go right 3. Draw my dotted line through that. I'm going to go back to my origin and go left 3. Draw my dotted line through that. Now, holy cow, look at all those sections that we've created. Yeah, you're partly right on that. Very good. What Christian is saying is that one of these sections is going to have a parabola-looking thing in it, and that's true. What I would do, what I tell students to do, if you're going to make an old school input-output table, is I would use your vertical asymptotes. So I would pick a few points, a few x's to the left of that, it's like -4, -5, -6, and see what happens over here. I would pick a few here in the middle, so like -2, -1, 0, 1, 2, see what happens in here. I would just break this down into those 3 pieces. This is 3, so 4, 5, 6, plug those in and see what happens there, okay? Or go to your calculator and get those out of the table. So we've got that, so let me go get my calculator and we'll use some. X squared minus 9. That's pretty cool. But just a second ago, when I was showing you to do those 3 sections, you can see that clear as day there, can't you? So my dotted asymptote that I drew, I would have picked 3 points over here or so and drawn that one. And then here's that parabola looking one Christian was talking about. So there's your three sections. So if you need those, come on. Let's go look at our table. You can get your points, scroll through there and get all those points. You okay on that? That's pretty cool stuff. That's a good looking graph. I like that. Okay? Ready to look at the last scenario? Feel okay?
So are all the equal to's gonna look like that?
Not necessarily. Probably similar though. Depending on, like those were squareds, so depending on how much higher that power got, they might do more. Yeah, try it out, play with it. It's interesting.
Do you have a plastic bag?
No,
Like a Ziploc bag?
I do not.
Because I don't want to lose the screw.
We got one more graph to draw. Let me get it done.
What the?
What did you put in? Oops. That's cool. What power was that?
5?
Whew. Y equals x squared plus 3x minus 4 over x minus 2. So all of our scenarios, what we're doing is comparing the degree of the numerator, so I've got a 2 on that, to the degree of the denominator. So that x is an x to the first. So what kind of sign would go between 2 and 1 here? Greater than, okay? So when our degree of the numerator is greater than our degree of the denominator, there is no horizontal asymptote.
So where did we get the 2 greater than
The degree of the numerator, highest power, over the degree of the denominator, highest power. Okay, so the first scenario, just to backtrack and make sure you got a note if you needed it. The first scenario, our numerator was less than the denominator degree, y equals 0. Our second scenario, when they were equal, you put their coefficients over each other. And in this scenario, when the numerator's degree is bigger, there's no horizontal asymptote. Okay? Still got to check for a vertical asymptote. Do we have a vertical asymptote here? Can you just tell it to me without having to do anything?
It's 2.
2, right? Set your denominator equal to 0 and solve. So it's going to have a vertical asymptote there. So if I were going to graph this by hand, making my old school table, I would pick some points on both sides of that. See, I just have one divider now. That last graph that was really cool had 3 dividers. But now I've just got, pick some numbers to the left of that. So like 1, 0, -1. Pick some numbers to the right. So like 3, 4, 5. Okay? Or just go plug it in your calculator. Y'all plugging it in already? I want to plug it in too.
Oh, I should have done all that in the spreadsheet. 2.
What's this doing?
Okay, it's just like a bent parabola.
Yeah, kind of like, what was y'all doing?
You.
What is it? What is the number? The number? The top. That's what it is. 2x squared.
No, it's x squared plus 3x minus 4. Is that what y'all's look like?
Yes.
Yes.
I think we're missing a piece. Let me see if I can zoom out.
Plus 3x. Minus
Are you zoom out?
Hit zoom, and then 3 for zoom out, and then hit enter again. we go. Whew.
Oh, yeah.
Now, how would you have known to do that though? How would you known you might have been missing a piece? We had a vertical asymptote, and that vertical asymptote split that graph into two sides. So that would have been a good clue. Now, I hit zoom and then zoom out and then hit enter. So you're gonna need, if you're taking ACT or you're doing the Aspire, you're gonna need to get back to your normal screen at some point. So that's always zoom 6. Zoom standard will always take you back to a normal screen. Okay? Alright, pretty cool with that, alright on that? Tomorrow, I think, I don't wanna get you excited before I make sure. I think tomorrow's when we start getting to my fun stuff. Some ninja math. Yep, there's some ninja math starting tomorrow. Might have to get the ninja sword out. Start slicing some stuff away. That's a good deal on that.